Hello, and welcome to today's session on MLOps. We're excited to speak about this topic, and we have time set aside for questions at the end of the presentation. As was just mentioned, please post your questions in the chat, and we will address them in the order that we get them at the end when we talk about Q&A. So first, some background on presenters. So I'm Claire Walsh, and I have over 25 years of experience with technical solution delivery, mostly in the area of data and analytics. I joined Excella almost 6 years ago as the data and analytics practice lead, and now as the vice president of engineering and services, I lead the curation and growth of all the consulting services we offer. And that goes across data engineering, AI, data viz, software development, agile design, and DevOps. Henry Gia is our data science capability lead at Excella, and he's responsible for advancing the skills and practices within our data science community through professional development, mentoring, recruiting, staffing, and enabling community collaboration. He has almost 15 years of experience working in the data science field, leading cross-functional teams to delivery success. He's also actively engaged in Excella's data science outreach programs with the Flatiron School and Howard University. So in today's presentation, this is what we're going to cover. First, we'll start with what is MLOps. Then we'll move into the 6 essential areas for an MLOps approach. And at the end, we will cover an agency use case to give an example of what this looks like in practice. So first, let's set the stage by talking for a moment about the continued increasing demand for AI. These statistics from Bloomberg Government show the projected growth of the AI market in the federal sector. Specifically, the defense sector is forecast to be $2.8 billion, and civilian agency spending forecast to be $1.44 billion in 2023. Additionally, in January, the U.S. Congress adopted the National Defense Authorization Act of 2021, or NDAA, which includes the creation of a National Artificial Intelligence Initiative Office to promote U.S. leadership in AI research and development, lead the world in development and use of trustworthy AI in the public and private sectors, and prepare the present and future U.S. workforce for the integration of AI systems across all sectors of the economy and society. Finally, a McKinsey global study in 2020 showed that 50% of companies surveyed had adopted AI in at least one business function. So the interest in adoption of AI is accelerating and is expected to continue. So with the increasing demand for machine learning and AI solutions, what is MLOps and why is it important? So most recent advances in AI have been achieved by applying machine learning to very large data sets. Machine learning algorithms detect patterns and learn how to make predictions and recommendations by processing data and experiences rather than by receiving explicit programming instruction. You've heard of DevOps and the advantages that that brings to software development. Well, MLOps is something very similar for AI and machine learning. This definition here from Forrester succinctly encapsulates what MLOps is. It's a combination of tools, technologies, and practices to support the deployment, monitoring, and governance of AI solutions. There's a lot of exploration in AI projects, a lot of figuring things out by experimenting, and to do this systematically and efficiently, we need the AI model implementation to be fast, reliable, and repeatable through the automation of tests and deployment pipelines, making sure our infrastructure is standardized all the way from dev into prod, and ensuring solid security is built in throughout. Because machine learning algorithms adapt in response to new data and experiences to improve without human direction, monitoring the AI model to validate that it continues to work as expected is really important, and it's a key part of MLOps. We need to monitor the model outputs to detect and correct for model drift over time. So MLOps introduces repeatability and automation into the processes that support AI solution training, testing, deployment, monitoring, and governance. Some of the benefits that you can expect to gain by introducing MLOps into your organization are listed here. And these include consistency of model results over time, increased reuse through automated testing and documentation, and rapid feedback loops for continuous improvement. So let's jump into exploring the 6 essential areas an MLOps approach needs to address to enable these benefits for your organization. The best way to get started with MLOps is to recognize that it covers many different aspects of the life cycle for machine learning solutions. Addressing these 6 areas here will build a foundation for an effective MLOps approach. By making progress in each area, you'll start to see benefits, even if you don't fully automate all of your processes right away. So the 6 areas are understanding business needs, data ingestion and governance, model development, model operationalization, model monitoring, and model security. Let's start with understanding business needs for an AI solution. To build effective AI solutions, you need to understand the business problem that they'll solve. This understanding will guide the build approach and provide evaluation criteria for model development and monitoring. However, AI projects are challenging and they don't follow a nice, linear, predictable path. We can't sit down and say, well, we'll use this and this data source and we'll apply this combination of algorithms to our model and we'll get exactly this output with a specific level of accuracy. It just doesn't work that way. There are many unknowns, and this means that there's a lot of exploration going on throughout an AI solution. Because of this, it's very important that we approach this work in an agile manner. Now, that said, agile for AI is not at the same level as maturity as it is in the software world. Often, people try and use the same version of agile they use for software development, so for example, Scrum, for AI projects. And without adaptation, this can leave everyone frustrated, claiming that agile doesn't work in these scenarios. Agile for AI isn't a fully solved problem, and we tackled this by leveraging our agile thought leadership and expertise, combined with our data science, data engineering, and DevOps experts to adapt standard agile approaches for AI work. The result is a repeatable agile framework that's proven and effective. We call it the Rapid Analytics Framework. The framework that you see here has 7 phases with feedback loops between many of them. You'll notice that the phases combine to look like a funnel with many ideas at the start of an AI project that are systematically refined into a subset using the learning obtained from each phase. The opportunity to return to a prior phase and pivot or refine is also supported. One of the main features of this framework is that it combines agile delivery with elements of lean startup. Lean startup practices address the uncertainty of first selecting the right problem and then moving on to the right solution approach. You want to make sure you're building the right thing to maximize value for the organization. Once an idea has evidence of high potential value, an iterative build and validation loop begins, with the process completing in deployment and ongoing monitoring. So in this framework, the ideate and explore phases support business understanding. During ideation, the focus is on collecting ideas, scenarios, and value propositions that we think will create value. These ideas are generated through discussions with users and stakeholders and documented. Associated data sources and possible success metrics are also captured to help prioritize which ideas, which scenarios to move forward. This is an agile framework that we're using, and we want to act, learn, and adapt rapidly. We timebox performing some initial prioritization of scenario ideas and then move into the explore phase. High potential value ideas are further assessed in the explore phase, learning more about the data available, finding patterns and irregularities, and examining data quality. The explore phase may also generate additional scenario ideas, and that's expressed by the idea of a refinement loop. Again, this phase is time-boxed with a review of what was learned, and a decision to proceed or go back to the ideas phase or the ideate phase is made. So when you're in these phases, to effectively document different scenarios for comparison and prioritization, we advocate the use of an assessment canvas. This is an example of a canvas format that we've put together for fraud use cases. The benefit of the canvas format is that it summarizes all the relevant information in a very concise way, and it helps make prioritization more systematic and transparent. Now let's move on to data governance and ingestion. So I think most of us know that machine learning solutions are only as good as the underlying data. Using an MLOps approach puts processes in place to make sure that data is effectively managed and governed so that your models remain as accurate as possible over time. Data ingestion pipelines must onboard all data sources reliably to fuel the model results. And these processes also need to apply data quality business rules, security, and access policies. Where data governance policies and quality metrics have been established, these should be applied automatically wherever possible. For example, using automated thresholds that trigger alerts or stop job processing when defined limits are reached. This could be setting a minimum level of data populated for key data elements to ensure completeness, or a maximum level of unexpected values for a data element to ensure data quality standards are met. Data volume thresholds for each source are also recommended to alert for unexpected peaks or drops in volume for further analysis. Encrypting data in transit and at rest and securing access in compliance with agency security policies is obviously required, and documenting data lineage throughout the entire ingestion process to ensure integrity and support chain of custody is recommended. When new data sources are used, engaging government's teams early supports timely updates to policies and any metrics related to them. Aligning back to the rapid analytics framework, this is happening during the explore phase of the solution, where we're evaluating different architectures and assessing the data captured for different scenarios to prioritize which ones to move forward based on expected business value. Data ingestion and data governance should be in place and automated as much as possible once you reach the solution phase. So now I'm going to turn it over to Henry, who's going to talk about some of the additional phases in an essential MLOps approach.
Thanks, Claire. So once the data has been ingested, aggregated, and pre-processed, a model is at this point ready to be trained. For a model to maximize its eventual business impact, it has to be performant in solving the business problems. To do that, we want to align the business metrics in terms of model metrics such as accuracy, availability, reproducibility, and scalability. So when we're ready to build a model, we adopt the approach of building in small increments and rapidly and regularly validating the technical correctness and of the added value of that additional increment. You can see in this diagram again that the iteration loops between these two steps. We continue to do this until we have the outcome that we have strived for. Sometimes, though, we may find actually we can't get to this work to the initial hypothesized goal that we originally wanted, because data science in itself is very experimental in its approach. So maybe a model with sufficient accuracy just doesn't run fast enough to be responsive, or the data doesn't support the kind of predictive inference we require it to be. So in that case, validation serve as a systematic way to cut our losses and learn from that dead end and pivot to a new solution, a new approach. So that concept is from something similar to lean startup concept, and it's absolutely necessary because of the inherent higher uncertainty involved in building AI projects. So moving on to the step of the model training itself. Most machine learning, right, there's a lot of variability in how these solutions are built, different algorithms, different deployment models. But for the machine learning in its core, often we look at it as three major components: representation, evaluation, optimization. So training a model is really the core step to trying to interpret the insights from the training data. So the first step to take is really the representation. So for example, if the data is in nice numerical values, right? So the representation is inherently already mathematical, so not much to do. But now if you look at the application of AI, there's a lot of unstructured data that's really presenting exciting opportunities, like image recognition or natural language understanding, or the prediction based on historical time series data. So all these data is really unstructured. So how do you represent it in the way that machine can actually learn from that? That is a challenge in the step of representation. So once the data has been restructured, transformed in a format that can be properly understood by the machine, we move on to evaluation. And this is where it's highly iterative, or the model gauges the prediction from its algorithms against the ground truth data. And there are hundreds of possible algorithms, often can drive to the best performance. So it's a very tricky selection process, and this is part of the uncertainty associated with building a machine learning solution. MLOps can really offer a lot of value in this repetitive step. It can automate most of the search process, running many experiments in parallel in an organized way, and even intelligently select the best performing ones. So some of you might have heard the term AutoML. That is kind of part of this application in this arena. Lastly, optimization is really how each algorithm learns as it reads over more data. So imagine, how much data does it take for an algorithm to identify interesting patterns that can be predictive? Optimization is really the different algorithms that can help to find that pattern the fastest. MLOps can also help in this step as well, similarly by speeding up the search, by really even to optimize the hardware against the particular mathematical computation needed to solve for this optimization problem. So since the entire approach, right, all three steps is hypothesis driven, often finding the right solution or even the best solution can be inconclusive and negative. But again, just because the finding is inconclusive and negative, it doesn't mean that that particular experiment offer no value to the project. Tracking these experiments is really valuable in guiding future experiments in the most promising direction. And that's another part of MLOps that can help you track experiments and also maybe even provide active guidance on where to go next. So training the model is not just involving the selection algorithms and optimizing computing, but also all this is happening in the compute environment. Managing that environment is also a critical component in making sure that we achieve that reproducibility and traceability piece. So for experiment to be repeatable, this is something that's very different from software development, is that it's not just the code that needs to be versioned. For experiment to be repeatable, the training environment is also a variable. So changing dependencies in what kind of packages are used, what kind of virtual environment or containers are used in that experiment, and also how to really repeatable randomness in how these algorithms start the compute, all play a factor. Making sure that the training environment is scalable. So this is somewhere that, if you are computing against a large training set, this could be a step that requires thousands, if not hundreds of thousands of dollars in total compute cost. So making sure your training environment can scale to that level and also help you manage the compute cost can really pay off big dividends. Versioning, as I mentioned briefly before, you want to version everything associated with what produces your model. You want to version the data, version the code, version the randomness, as well as the training environment. And of course, any compute that is, dedicated to just maintaining and running all the background processes that make up your training environment is needless overhead. So you want to make sure that, your environment is robust, but also as lightweight as possible. Also, lastly, this is something that is very exciting area, is that we see a lot more hardware and specific architecture and infrastructure being made to support machine learning. So why not take advantage of that advances? So make sure that the training environment have the proper hardware support and can really reproduce a lot of the technical specs you expect in production, can really benefit the readiness of your model for production. So let's talk about once you have a model. You might have a sense of triumph and you feel like you're close to the finish line, and you're absolutely right. It's a big step forward, but it's not a solution yet, and certainly isn't ready to generate business value. To make that happen, operationalizing a model is absolutely a crucial step to make that real. So MLOps introduces repeatable processes to take ML models from development into production, so that you can be confident that when a new improved model is ready, you can take full advantage of it. Your business can really, kind of benefit from that, and with confidence that is trained and deployed correctly, and use it with confidence. The model should be deployed to best serve the business needs. You can automate the ML production pipeline to retrain the models with new data, and that can happen in a few different ways. One is on demand. So if you have, essentially, this is almost like a service approach. If you deploy your model at the end of the endpoint or something like that, or socket, then you can allow essentially ad hoc on-demand predictions from your end users. You can also deploy it into a batch model where data can be periodically processed on schedule, maybe during off-peak hours, save some compute costs, but also not to interfere with existing, workflows in your business. The retraining frequency also depends on how frequently the data pattern change and how expensive it is to retrain your model. So some businesses might decide that it makes sense to do a periodic retraining to evaluate if the new model is an improvement. Other times, especially in extraordinary times like we live under right now, right? The market dynamic is changing. A lot of new policies, new benefits, new budgets are being passed to deal with the shifting conditions. Then it might be prudent to be more frequent in that training to evaluate the changing conditions more frequently. So the model update schedule also depends on how the model is really learning. So are you deploying static model, meaning that the model is fixed once it's going to production? Or are you experimenting with online model, meaning that even the model is in production, it is still learning from the continuous prediction, continuous consumption of that service by the end users. And then also, of course, ultimately, a lot of this really depends on the model performance degradation. We kind of expect all machine learning models to degrade in performance in production. The only constant in life, right, is change. Everything is changing, so is the data. So we're monitoring for model drift, which could be caused by concept drift. For example, what people consider to be essential goods under pandemic, right? That definitely has changed. Or it could be data drift. meaning that maybe all of a sudden, people are shopping with different vendors. So, what the data that vendor collecting is suddenly representing a different demographic or larger group of people. So that data might drift. So all these things also we're also considering is something new is that how do you optimize the end user experience? Part of that is really where does your model sit? Traditionally, a lot of the architecture is involved with the model being hosted in the cloud because training requires a lot of compute power and a large big data storage and all these things. And also compute tend to be pretty heavy associated with running the model itself. And then now we see there's, this movement called Tiny ML that can really kind of strip down the non-essentials of the model, compromise a little bit on accuracy, but make it really small so they can run on IoT devices, can run on your phone as part of an app, can run on smart cameras, smart devices. And, there's this emergence of this hybrid model where you can be training in the cloud, but deployed on multiple devices, as long as it makes sense to integrate seamlessly with your end users, kind of daily lives and their current workflow. So that's something to consider when you're considering how to operationalize your model, is how to reach your user in the way they're most comfortable with. So once we have touched on the deployment a little bit, releasing a model production reliably, frequently, minimize the risk, and maximize the speed to value, and that continuous generation of value using a feedback is definitely very valuable part of MLOps. You can think about how that can really maximize ROI for the investment in that project. And then once the model's in production, there's also last but not least piece of MLOps, which is monitoring. You want to watch over the model in production, make sure that automatically and continuously give you insight to how the model is performing against the real life data that is coming in right now and how that compares to your expectation before deployment. You want to can take actions if there's model drift or things that are happening that's causing degradation, or if it is impacting your business in a negative sense in an unexpected way. And then initiate any kind of repudiation, which often involves model retraining, or it could be that reassessing the scope of the model's usage, such as maybe a different model serves a different region or different time of day or different part of your user base. So let's go a little bit deeper into model monitoring. So the output of this stage is really triggered to execute the pipeline, ideally something automated in the MLOps process to execute a new experimental cycle to automate some of the more likely remediation steps. So one of the things you will want to do is to, in that pipeline, be triggered, either completely automatically or with human in the loop, based on speed, availability, or scaling. So if any of these key factors are failing, that will impact your user experience. Ultimately, that's really the goal of a machine learning product, just like any digital product, is to be needs to be in the hands of the users to make a real impact. So accuracy measures, there are technical ones such as overall accuracy, false positive, negatives. But again, you want to align that to the business metrics. What I mean by that, for example, is that in a case, for example, if you're a drug maker, 99% accuracy in predicting falseness of the effect might not be sufficient, because maybe the naive guess is that if disease is rare enough, if you predict no one ever get that disease, the accuracy is extremely high. But in those cases, you want to align the accuracy measure to what makes sense to the business. And frequency of use is also an important metric. This is something that a flexible MLOps deployment pipeline allow you to possibly do A/B testing of various models, and also various deployment methods. Maybe you can compare the accuracy of Model A and Model B, but also compare the usage adoption rate if it is deployed as part of an app or part of a web app. We just want to also touch on this very interesting but also crucial topic of model security. So I think people have been talking about how vulnerable machine learning models is to various kind of methods of compromise or hacking. So I just want to touch on a few of the more popular examples and how that can become kind of a weakness in the solution, but also how MLOps can be part of the solution to take a proactive preventative approach to stop it from happening. So adversarial attacks essentially is a very generic term where somebody's maliciously trying to manipulate the outcome of your model by small manipulation in the data they're sending. So if you look at the graphic here, it might be a little bit harder to see, but if you see there is one pixel that tends to be either black or completely white in each one of these pictures. This is called single pixel hacking. So if you have some of the earlier image recognition or image classification models, they found that you can actually change a single pixel in an image and then confuse the model to the point that it very confidently reaches a wrong prediction on what the object is to be in the image. Another one is data poisoning. So a machine learning model very much depends on the completeness and the faithfulness of the training data to learn, right? It has to learn from accurate and complete data sets for it to be intelligent and making predictions. So it is possible that if your data is biased, or if its data is intentionally being biased or made incorrect, your model is obviously as a byproduct that becomes inaccurate. So something similar is online model attack. As I mentioned before, if your model is doing online learning, meaning that while in production, it's still continuously learning from the new data that is coming in, somebody who is aware of that can potentially manipulate your model's learning by sending you new false data. So essentially, it's almost like your model's learning from fake news, right? It's just like humans. If you're consuming all the fake news articles, all of a sudden your sense of reality gets a little twisted. Same thing with these online models. If they're just learning from new incorrect data, they become, their predictions start drifting in the wrong direction. And denial of service attack, yes, so I see there's some question here. Sorry, I'm just going through the bullet points on this model security slide here. So just on the DDoS one, denial of service attack. If your model is served as an endpoint, right, you're just as vulnerable as other web services for denial of service attack. But what's also another tricky layer of complexity here is that if they can figure it out, or through the repeated sending of these services, they can figure out some of the problems might take your model longer to make a prediction. So that they can use that information to make their denial of service attack even more effective, meaning they only send you the complicated questions. And a transfer learning attack. So a lot of the models, vast majority of them, are not trained from scratch. They're based on some kind of architecture already pre-trained using a much larger data set. This provides a lot of benefit because it saves you on the cost and the time required to training, and also doesn't require nearly as large a training data set to start with. But also means that if someone has trained their attack on the basic framework that your model is based on, there is a high likelihood that their attack will be effective against your current models as well. And data phishing. So this is something that if your model is training on confidential data, this is can be a kind of profound problem, because if your model is overfitted, or if your model is trained on very large number of, for example, for demographics, you have a lot of information about each person, but not a lot of people. by repeatedly hitting your model to make predictions, you can reverse engineer the data set that was actually used to train your model. So that kind of violates the confidentiality of your data set. And so let's move on to the kind of how we do MLOps in real life. We cover a lot of concepts and theories. So here's an example how we have proven MLOps can equal larger business value on real projects. So one example I want to walk through is, fraud detection, supporting the United States Citizenship and Immigration Services, Fraud Detection and National Security Directorate. We were part of the Risk and Fraud Analytics and Development, or DevSecOps project, which is the engagement that leverages advanced data and analytics, agile approach to help mitigate immigration fraud and immigration benefits fraud. So we led the we were building a scalable text comprehension semantics comparison engine with natural language processing, augmented by similarity search algorithms. The immigration agents and investigators previously were doing this on a completely manual process. And that was slow, manual, and limited by the scope of each agent's experience and their capability to read through documents. With this solution we built, now it not only is their workflow automated, but also now they have the ability to, kind of previously unavailable ability to compare suspicious unstructured data across their entire historical archive, automatically servicing valuable leads and identifying, emerging patterns in fraud in near real time. So this approach has really kind of dramatically transformed, how they approach AI. We provide a framework and process that can help them decompose the process of creating new ML models and maintaining current ones and make it transparent for them. They have visibility into your models and control over their improvement. And it is, this kind of workflow is becoming the common core, allow them to develop future AI projects using the same methodology and process. So imagine, in the near future, an agency with hundreds, if not thousands of models in production. It is essential to have a standardized way to not only bring new models into the fold, but also productionize them in a way that's scalable and also maintain the same transparency across all of them. And of course, following the same process hundreds, if not thousands of times, you get a tremendous amount of economy of scale. And that means that that comes in two ways. One is new project can reach production faster, and also ongoing maintenance costs can be cut into a fraction. And also the maintain transparency piece is something that is hard to put a dollar value on, but it's definitely something that will be a requirement in the future because we see a general trend of GDPR, CCPA both have specific sections and clauses requiring this, and also we see executive orders mandating the same thing. So it is our belief that every single component in the process should be reusable, traceable, and transparent. We try to avoid our process. Easily avoids static and hard-coded models that's difficult to understand and nearly impossible to change. We also weigh the choice of the algorithm when building the model that drive the model in terms of its interpretability. Some of the models, even if the algorithm can be the best performing one, but if this interpretability does not reach the needs of the business, we don't want to go down that route and lock into gray box or black box model that will essentially be obsolete when transparency is a requirement. And we also, in the MLOps process, we also often expose the ML model as a service, but also always leave the flexibility to, recompile, optimize the model for other, new technology in hardware or a new paradigm in architecture. So that flexibility is something made possible by the MLOps approach. And I think we're just wrapping up here. I do want to leave some time here for question. So thank you all for your time. And I'm happy to be able to talk about all this interesting topic.
Thanks, Henry. So if anyone has any questions, please post them in the Q&A, and we will take those. I think we had a couple that maybe we were going to start with. Katie? Okay, so question, what are some next steps and sources to learn more about this topic? So Henry, do you maybe want to share some of the things that you've used to get more information?
Absolutely, yeah. So I would say that, the three large cloud platform providers have put quite a bit of work, good technical rigor, as well as, kind of a compilation of the content on this. So Azure, GCP, and AWS both have great resources on covering some of the basics on what they believe to be best practices in MLOps. Their diagrams and architecture might vary slightly, but I think the major components are all in agreement. There are a couple of good books out there on this topic if you are interested in going a little bit deeper in depth. A lot of them are fairly recent because this is a topic that is still kind of evolving, slowly maturing, but very recently came into more of a mature state, but it's still evolving as new technology emerges. I think those will be great places to start.
Excellent, thank you. So another question, do you have any real world examples that you can share of model security threats?
Sure. I think, the good news is that I don't believe there's any massive compromises in, we have been hearing some really kind of groundbreaking hacks recently, right, of networks, whether it be pipelines or, the food supply chain or government agencies, right? So we haven't seen hacks and compromises of machine learning models on this scale. But I think we do see that there are many examples where people are essentially identifying vulnerabilities that is already inherent in the model, and sometimes people are taking advantage of it, maybe not in the malicious and for economic benefit or financial gains, but we're already seeing that some happening. For example, online learning, right? So one of the really unfortunate example was that Microsoft originally put a chatbot to train to interact directly with end users on Twitter. So that's a case of online learning. So it will learn as it converse more with real people. Unfortunately, people started teaching it a lot, bad language and, essentially giving it a false sense of what normal conversation should be, how to be sociable, how to be friendly chatbot. So that's an example of, how a model can be compromised. So eventually, they consider that like a lesson learned failure, and they immediately pulled the bot offline because it was generating very negative headlines. But imagine that model, if that chatbot was something in production to not only interact with your customers, but also facilitate internal communication. What if that is maliciously mistrained to, kind of contain false information, false logic? All right.
It looks like we may have another question that came in.
So I see, Katie, the question, what are some challenges organizations will face in the adoption of MLOps? Great question. I think one of the things is really just understanding that, MLOps is something that is a cost cutter, not like not a cost center, right? So it's not something that you necessarily need to worry about that it become overhead cost on your plan to build an AI solution, but it's more of something that helps you to make sure that not only in your first ML, like AI or ML project, that you have a higher likelihood of reaching success, but also something that help you, lower the cost of future maintenance and lower the build cost for future models. I think some of the toughest challenges really is just having that initial conversation about, why it is why it shouldn't be an optional nice to have, but it should be considered, an organic, natural step to take in the journey to become an organization that contains AI solutions.
Yeah, I'll add to that too. I think that some of the rigor of automation, which obviously is another key part of MLOps, while there is a lot of automation and tools and options for kind of your classic software development, that area is still very much evolving for AI and data solutions overall. And so I think, just trying to eliminate manual components and understanding the different options there, it's not necessarily like a completely written playbook at this point. So I think that can also be another challenge. All right, so we have another question. What skill sets should organizations be investing in or building if they want to use MLOps? So Henry, I'll start on this one, and then if you want to jump in. But I think very much something that we really strive for at Acceler is the idea of having cross-functional teams. And so just as you would for software, you kind of want that full stack team that has the depth of machine learning and data science, statistics, expertise. You also want your data engineering experts that are really going to do a great job with data quality, data pipelines. We typically advocate that you have an agilist and an analyst and also a DevOps engineer. So you have this, kind of two-pizza team that has the variety of skill sets and depth of skill sets to be able to deliver something that is robust, reliable, reusable. Overall, like from a data science perspective, yes, obviously data scientists, especially if you're a unicorn data scientist, you've got a lot of those skill sets, but we've really found value in having people focused in specific areas. So it might be a little bit more skill set expertise focused than maybe like a typical software delivery team from an agile perspective, but it does give you the depth that you need when you're working on some of these very complex and also large scale machine learning solutions. Do you want to add anything, Henry?
I think you covered, a big part I was going to say. And also, I think is really, this might be a more vague description. I think it's just going along the vein of that cross-discipline team, a team of people who are really curious and willing to pick up new skills and learn new things. It's really nice to have in that environment as well, because this is an area that is still evolving and a lot of things are changing very quickly. It's not very uncommon for us to recommend implementing a solution that was a paper 6 months ago. So people who are, keep their head up on what's happening in the general environment and always ask the critical questions like, is there something better we can do to solve the problem, can really go a long way.
Yes, agreed. So we've got about 10 minutes left. Another question came in. Can you go over the differences between the management and delivery of AI projects and more typical software development projects? So I think maybe we can both take a stab at answering this. I think some of this definitely goes back to the reason that we created the rapid analytics framework that we talked about earlier. Is from an agile and DevOps perspective, they both evolved in the software world, and there's a tremendous amount of value with the fast feedback loops, the DevOps mindset, continuous delivery. Obviously, we want that in our AI projects. And so I think that it's really kind of taking that same mindset, and rather than just doing Agile and, taking a framework like Scrum and saying, all right, I'm following all these practices, so therefore I should get the, faster delivery results, right? It's not about that. It's really about, absorbing the principles of Agile, the DevOps mindset, understanding like what you need to do and how you best adapt techniques and processes so that they align to those principles. So we talk a lot at Excella about being agile and having a DevOps mindset versus doing agile. And the rapid analytics framework we developed because we saw that while, Kanban sometimes or a Scrum-bound approach can be effective in data projects and AI projects, there's really, as we talked about, so much exploration that's happening at the beginning. Even if you know that there's a great use case that, for example, fraud, lots of fraud out there. Where do you start? What's going to get you the most value? What's going to get you kind of the biggest return on investment? So that's hence the idea of, if you look, we're not creating anything that's a brand new kind of agile technique, but what we're doing is taking many different aspects of different frameworks, different techniques, and bringing them together in a way that makes sense for AI projects. So I think that, to me, is one of the big differences. Is it's still agile. You're still leveraging the the mindset and the concepts of continuous delivery. Automate everything, but you're doing it in a way that is more aligned and easier to follow for an AI solution and its end result and how it needs to get built and monitored. If anything you want to add to that?
I would say that, maybe on the ground, a little bit more granular part of the management is also the communication. So I think it doesn't matter how much AI component is in the solution, right? To make that into a product, you still need software engineers and software engineering tasks in that project. So facilitating communication was really going on with the AI part of it, and how to build either that is a small component, so how does it properly plug into the existing tech stack, or if the AI components is the main part, then how do you wrap the software engineering around that to provide the best user experience? That communication is absolutely crucial. And also, something that you see a lot is how do you follow the agile philosophy to seek continuous feedback. For AI, as we talked about before, some of it, the experiments is highly uncertain, can result in negative or inconclusive findings. But also, even if you have a successful finding, right, the measure of success can be highly technical and mathematical in machine learning. So MLOps also, drive you to provide some kind of feedback in the mechanism, maybe some kind of dashboard, or maybe, kind of a simple kind of prototype to allow the end user to see the impact of your initial findings. That can also drive a better feedback loop from the customer.
Agreed. Okay, a few more questions came in. This one's interesting. So, can someone use MLOps if they aren't in the cloud yet? So, I don't know if you want to start on that one. I certainly have some thoughts here. Do you want to maybe go first?
That's a good question. It's almost like a brain teaser. How do you facilitate? The collaboration part of the MLOps without cloud? I would say it would be difficult. It's not to say it's not impossible, because a lot of it, we talk about version control, right? Without cloud services, it would be really difficult. Assuming you still have GitHub and kind of container repos and things like that help you out, but you just don't have cloud compute. In that way, I would say that you can still use some of the CI/CD pipelines associated with GitHub and any of the container repo you use to help facilitate with that version control and the collaboration. You just are completely constrained when it comes to scalable training environments or, kind of reproduction of, production environment in your training environment. So that would definitely be a setback. So ideally, I would recommend, probably some kind of cloud, maybe a hybrid architecture can benefit the team in that way.
Yeah, I agree. I think really the scale, also the services that are available, can be difficult to do in an on-prem scenario. So I think the advantages of the cloud, obviously, in terms of scalability and also the ability to scale up and down, right? The elasticity, and also the cost efficiencies. I think, there's a lot of good reasons for adopting this in a cloud, or maybe, like you said, in a hybrid cloud approach. To do this entirely on-prem, I think, the return on investment or the expense might be higher than you want it to be. Okay, I think we have time for one more question. We've got about 3 minutes left. So what are some important considerations when deciding when to use AI, or what problems to apply AI to? And I know we've seen this, right, where people are like, great, I want to use AI. And they're like, what do I need to do? And so you're not necessarily coming with a business problem or an opportunity. But when would you say, is a good scenario or application of leveraging some of these more advanced AI solutions?
I think so. AI has definitely, kind of broke a lot of these preconceptions on what problems it can solve, right? Like one interesting little tidbit is one of the things that people can tinker with is that they decided that they want computers to automatically generate a game. Right? It used to be computers can learn to play game through AI, but now they're teaching AI how to build a game. So now you essentially have adversarial environments where, AI can create a game and another AI can play the game. So I just want to use an example is that, sometimes you can think outside the box, what is really possible with AI. But on the bottom line, I think for a lot of business use cases, a good starting point is really looking at the state of your data, how complete it is, how big it is. Is it well curated and clean? Otherwise, even if you want to start on a journey, a lot of that initial effort and time will be spent on trying to catch your data onto to that quality and size. And once you have that, then I think is a combination looking at where your data, kind of what does your data track, and also within your business, where does it hurt? Where's your pain? What's limiting your growth? What's costing you money? What's costing you time? What's slowing down? So those are the things where the data tracks and where your pain is, where that overlap is a really ripe area to discover some opportunities. Great.
Well, I want to thank everybody for joining us today. Thank you very much, Henry, for your insights and expertise. And I think at this point, we are right at time, 59 minutes. So again, thanks everybody for attending today, and we appreciate you and the questions that were submitted.
Thank you all.
Okay, goodbye everybody.